Scientists have discovered a new window into the Earth's violent past. Volcanic rocks collected on Baffin Island in the Canadian Arctic suggest that beneath it is a region of the Earth's mantle that has largely escaped the billions of years of melting and geological churning that has affected the rest of the planet. Researchers believe the discovery offers clues to the early chemical evolution of the Earth. The newly identified mantle reservoir dates from just a few tens of millions of years after the Earth first formed from collisions of smaller bodies. This reservoir likely represents the composition of the mantle shortly after formation of the core, but before 4.5 billion years of crust formation and recycling modified the composition of most of the rest of Earth's interior. This time was a key phase in the evolution of the Earth. The research is described by Carnegie Institution scientist Richard Carlson, lead author and former Carnegie postdoctoral fellow Matthew Johnson, now at Boston University, and co-author Don Francis of McGill University. The scientists targeted Baffin Island because rocks there have anomalously high ratios of helium-3 to helium-4. Helium-3 is generally rare within the Earth. Most of it has been expelled by volcanoes and lost to space over geological history. In contrast, helium-4 has been constantly replenished within the Earth by the decay of radioactive uranium and thorium. The high proportion of helium-3 suggests that the Baffin Island lavas came from a reservoir that never got rid of its original helium-3 because it had not been subjected to the extensive chemical changes in most of the mantle. Lead isotopes and lava samples confirm the age of the reservoir at between 4.55 and 4.45 billion years old, an age only slightly younger than the Earth itself. The early age suggests that the reservoir existed before the formation of the Earth's crust and before plate tectonics mixed the crust back into the mantle. Many scientists believe that the Earth's early mantle was similar to meteorites called chondrites, but that the formation of continents caused it to become depleted of so-called incompatible elements. This new research suggests that the Earth's mantle was depleted of incompatible elements even before continental extraction. This suggests either an earlier differentiation event or that the Earth was initially formed from building blocks that lacked these elements. The early differentiation model involves a global magma ocean that produced a crust before the crust that exists today. Because it was rich in iron, the crust was buoyantly unstable and sank, taking the incompatible elements with it. The research appears in the August 12th edition of Nature. This is John Strom for the Carnegie Institution.